Pre-announcements to Carl Mason, and then I'll outsource the introduction of our wonderful speakers to Ken. So,
thank you. After the seminar, the 39th cohort will be holding a poster session right here. Projects are based on the American National Election Survey under the loose guidance of Dennis. We would very much appreciate it if you can stay around and give us your feedback and unconditional praise.
Great, so we're delighted to have a return of Sarah and Romesh, and to introduce them, Ken has kindly agreed.
So, yes, we're happy to welcome back to our favorite and our most distinguished graduates. It's hard for me to believe that there's a whole generation of new people who don't remember you, but Sarah and Romesh were key figures in the in this department and group over the whole of the from 2002 onward. And Sarah was a member of Cohort 24, and actually a UC Berkeley graduate who then came to us and completed her PhD in 2007. And if I'm right, Romesh joined the cohort of Cohort 26, and after extensive field work completed his PhD in 2013, and they are three demography couples that I remember over the course of the time. Sarah worked with me and studied topics which she's later carried on in many varieties in looking at the later effects on aging of midlife or early life experiences, and her thesis dealt with effects of menopause, trying to separate out immediate and transient effects of menopause on cognitive and mood aging from those longer term effects, and she used the Wisconsin longitudinal survey data, a set of follow-up data that had just become available. There were tense days as she waited for the data, but as it came, she crafted an important dissertation. From there, she went on for NIA positions in London and Bethesda, as I remember, and then on to Galveston, Texas. And I guess that was a good place, but not a very happy place, as I recall. And I don't think I have the whole sequence, but you were then at the University of Maryland.
Right.
And is there anything between Maryland and Columbia? From Maryland to Columbia, while Romesh was on assignment in some of the most difficult places in the world, working on human rights demography, pioneering our department emphasis in human rights demography. And remember, most seriously, his times in Beirut and amid some of the violence in Syria. But now they are back in New York, which we hope is a safer and happier place, living in Brooklyn, and they now have a son whom we are hoping to enroll in Cohort 61. So again, in demographic activity, so their interests span a range of those portions of demography of most direct import to the health and quality of life of people in society. It's published very widely in a series of topics related to it, many of them related to the topic of our talk today, or the life environment and later life, in all those facets that we have to look forward to. So it's a real delight to have Sarah and Romesh back with us today.
you, Ken, and thanks everyone for that warm welcome. As Ken has mentioned, I have lived in 6 cities since graduating in 2007, and Berkeley remains my favorite. So it's really nice to be back. Today I'm going to be talking about aging. And these were ideas I really started thinking about when I was a graduate student here. And at the same time, in my own family, I was very fortunate to watch my grandparents aging very gracefully. And so I started thinking about things like, well, for someone like my grandma Ruby, what are the current factors that either support her health or are challenges for her? And for her, she still walks 2 miles a day and has a very active social life and is almost always hanging out with her friends or with someone from her family. And so she has a lot of support for her current health. Today I'm going to argue that when we think about the health of older adults, and I'm going to focus on cognitive aging, we need to understand not only what's going on with them as older adults, but also what happened to them far earlier in life. And that is because of changes that happen early in life that could have direct influences on brain health later in life, and because what happens to us early in life influences what happens to us as adolescents and all through adulthood. So the plan for today is I'll give a bit of background on how this project came about. I'll then take some time to give some definitions and some background on dementia. I'll talk about why a life course approach is particularly suited to this set of questions, introduce data sets I'm using in this overall project, and then for the remainder I'll focus on projects related to one data set in particular and talk about some recent extensions of these ideas. So this is work in progress. I definitely welcome your feedback and suggestions, and feel free to ask questions at any time. So my current appointment is in the Neurology Clinical Outcomes and Population Science Division, also known as NeuroCore, in the Department of Neurology at Columbia University. So this is my office, and we are up here at 168th Street. So we're in northern Manhattan, and the main Arts and Sciences campus is about 50 blocks south of where we are. I realize the Department of Neurology is not a usual home for someone who graduates from this department. And just as the way that my path after graduating worked out, my appointments as a faculty member have been in professional medical-related schools. And I think the niche that I've carved out for myself is someone who understands population science and who can help translate some of what the clinicians are seeing into these more population-based studies. So the project I'm going to talk about today actually began in 2003, and I say that because that is the year I took Econ 275 with Ron, and he introduced the class to 2 sets of readings that have been instrumental in the development of this project. The first was the nun study. So in this study, sisters of a particular order were studied later in life. And something unique about the study was that when the sisters entered the order, they were asked to write something about their background. And so the sisters who wrote more complex paragraphs, who wrote longer paragraphs, were at decreased risk for dementia when they were older adults. So this was really my introduction to thinking about how there's a life course approach to cognition, and also starting to think about creative ways to use data from early life in collaboration with data from older adulthood. The second set of readings that Ron introduced the class to related to height, in particular the work by Robert Fogel. And many of the readings focused on Fogel's work from the Union Army data set, showing that men who were in the Army who were taller had better outcomes later in life in terms of health and labor outcomes. So I remember I was just really interested by these ideas, and for the term paper for that class, I don't remember the exact topic, but I remember I wanted to consider a life course approach. So I went to Ron's office hours to tell him about my project idea, and he said, "Sarah, this idea is cool." So I thought with an endorsement like that from Ron, this must be a useful way to carry forward with my research. So as Ken mentioned, I was very interested in focusing on cognitive aging with a life course perspective in my dissertation. But one of the problems I ran into was to really focus on cognition. I couldn't find a data set that I was going to have access to in a timely manner. So Ken encouraged me to slightly change the question. And so as Ken mentioned, I ended up just focusing on the transition from midlife to older adulthood looking at menopausal symptoms and later mental health and physical health. After I finished my degree here, I went on to a 2-year postdoc sponsored by the National Institute on Aging. I spent the first year in London at University College and really focused on women's reproductive health over the life course. In this postdoc, I had access to 2 of the British birth cohorts where the government started collecting data at birth and has collected data through the present on these folks. The second year, I returned to Bethesda. And just a fun fact about NIA is that the NIA offices are not actually on the main campus. I was in this small office in downtown Bethesda, but the majority of the NIA offices are actually in Baltimore, and they share a physical space with Johns Hopkins. So these are the intramural labs at NIA. And when I was at NIA, I was part of a lab that had an expertise on physical function and disability. So got to continue the projects on life course and then start to think about these types of outcomes. So the first 2-year experience was really wonderful in terms of the research experience. I realized that because both of those labs were intramural labs, and if I were to stay in academia, that I probably would not remain in an intramural lab, that I wanted to get experience in an extramural setting. So I moved to Seattle to the Group Health Research Institute. Kaiser just acquired Group Health last year. And what I didn't know at the time, I knew that group health was going to be a really fantastic place to be, but I didn't realize how much else was going on in terms of science in Seattle. So group health is here. This is Denny Triangle. This is South Lake Union. This is where Amazon is now, which wasn't there at the time I was. But Fred Hutchinson Cancer Research Center is here. And then the University of Washington is up here on the east side of the lake. So lots going on in terms of public health. One of my goals for this postdoc was to start to think about how I could apply the formal demography techniques I had learned here in this department to epidemiology data sets. And I was chatting with the executive director of the institute, and he told me about a study that he was running that is an incident study of dementia in members of group health. And he said, why don't you think about how you could use this data set to apply some of those demography methods? And so that's what I did. I started using his study, which is called the Adult Changes in Thought Study, to estimate life expectancy with and without dementia. So to me, one of the unique things about this data set was they had a very clinically sound dementia diagnosis as opposed to waiting for someone to self-report dementia diagnosis. And in the literature, some of the other papers looking at life expectancy with dementia were relying on self-reported dementia or were only using cross-sectional data. So I was really excited about using this particular study. So I left group health after a year, and then I made 2 more moves, and all during this time I continued to work on this paper, and it was finally published 3 years later. In addition to looking at life expectancy with and without dementia, we also looked at incidence by age, so the onset of dementia by age. And we found that dementia incidence increases with age, which at the time was an important finding because some similar cohorts throughout the world were showing, some were showing an increase with age, some were actually showing a leveling off with age. In terms of the life expectancy results, we found that in terms of absolute number of years for life expectancy, lived with dementia were longer for women and those who had at least a college degree. But when you then looked at life expectancy with dementia as a percentage of overall life expectancy, we saw that these 2 groups actually had a smaller percentage of life expectancy with dementia compared to their counterparts. During the peer review process, one of the reviewers asked the question, does the ACT study have information on weight? And although the reviewer didn't ask explicitly, the main question was really about a vascular risk pathway. So in particular, people who are obese are more likely to have vascular disease such as stroke that could result in dementia. And so I asked the co-PIs, I said, I'm sure we have information on weight. I said, I think it's probably beyond the scope of this particular paper, but maybe we could do an extension paper. And they said, we sure do have weight, and we also have measures of height, head circumference, knee height, and arm span. So then I got really excited because with these additional anthropometry measures, the story was not just about vascular risk, pathways to dementia, but now could be a life course and a development story. So Paul Crane is one of the co-PIs of the study, and he said, sure, you could write a follow-up paper, or you could write a K award application. And by the way, if you want to write a K award application, I'd be happy to be your primary mentor. So I took Paul up on that offer, and the application ended up getting funded. So just some lessons learned about this process. I submitted the first, yes. So I submitted my first application in 2014. And the funding didn't come through until the end of 2016. And so I did a revision, but there was still this very long gap between when council met for the revision and when the funding started. So at NIH right now, there are 2 pots of money. One is for anything related to Alzheimer's disease and related dementias, and the other pot is for everything else. So at the time my application was being reviewed, you had to have the words Alzheimer's disease in your title and your abstract. Because I didn't, and I had to convene a committee to decide if my project was indeed about Alzheimer's disease. So the moral of the story is, if you are writing about Alzheimer's disease, please remember to use those words in your application title and abstract. The second set of lessons learned, I just wanted to share for those students who might be thinking about writing a K award in the near future. There are several non-traditional aspects about my K award. The first is that I graduated from this department in 2007, and I submitted the first application in 2014. So traditionally, K awards, we think of them as for people who are really starting out, and I thought, I don't really know if this is going to be a sellable story, but I was able to talk about how these experiences I had as a postdoc and as a faculty member, and how now was really the right time for this project to take shape. The second non-traditional arrangement is that his appointment is at the University of Washington, and at the time I wrote the application, I was already on the East Coast. And somebody at that institution told me I shouldn't even bother applying because if my primary mentor were not at my same institution, I would never get funded. However, I had worked with Paul on this previous paper, and most of that paper was actually written when I was no longer in Seattle. So I was able to say that to the reviewers, and everyone was fine with it. So my advice is, if you have a non-traditional arrangement or an idea for a K award, as long as you can justify it, and if you talk to your mentors about it, you talk to your peers, people think it's a reasonable idea, that you should think about going for it. Okay, so now I'll shift gears and talk about some background on dementia. The definition we're using today for dementia is a decline in cognition that is severe enough to impact someone's daily activities. In terms of lifetime costs, the recent estimate was $320,000. This is over the lifetime, with the family accounting for about 70% of those costs. So certainly the burden of dementia, it affects people with dementia, but there's also a huge family component. In terms of common causes of dementia, Alzheimer's disease is the most frequent cause. Vascular causes, such as stroke, is another common cause, as well as Lewy body disease, and this is the type of lesion associated with Parkinson's disease. We know that there are genetic components to Alzheimer's disease. For the particular types of there are genetic components to dementia. And for early onset of dementia, so this is dementia occurring by the 5th or 6th decade of life, that there is a strong genetic component. We know that for Alzheimer's disease that has a later onset, that ApoE is one of the genes that is most important. So as with any gene, we get 2 copies of the gene ApoE, and if you have 1 or 2 copies of the E4 variation, you are at increased risk for Alzheimer's disease. In terms of how is a dementia diagnosis made, importantly, dementia diagnosis occurs when someone is alive. So certainly there is pathology that is associated with Alzheimer's disease, but if that person has that pathology but never had cognitive impairment while he or she was alive, right now we don't consider that person to have had dementia. Some of these definitions may be changing with improvements in imaging, so that now in the near future, we will be able to see much more about a person's disease status while they're still living. Right now, the best way, the most accurate way to look at neuropathology is to wait until autopsy. And of course, that is discordant with this definition of having cognitive impairment. So dementia diagnosis includes cognitive tests, also a medical exam and consideration of medical history and complaints, a neurological evaluation, and in some cases imaging. And these last two are often to rule out other causes like tumors that could be impacting someone's cognition. So this figure shows the estimated number of people with Alzheimer's disease in the US in 2010 with projections through 2050, and this is using census from 2010. So I just want to point out this is just the number of people with Alzheimer's disease, so it is not new cases. And we see this sharp incline during this time period, and we see that most of this increase is coming to people who are age 85 and over.
And can you talk about the plateau and what people are assuming is going to happen? Are they assuming progress is going to be made in age-specific incidents, or?
So yeah, that's a really good question, Josh. So some of this, and we'll come back to this a bit later, but we've actually been seeing a decrease in the overall incidence of dementia, including Alzheimer's disease. And so some of that is largely attributed to increases in education. Some of that may also be related to increases of the standard of living in early life. So that would be my guess there. And then also improvements to risk factors like vascular causes of dementia. So smoking, obesity, keeping other comorbidities like diabetes and hypertension under control. Yeah. Yes?
Sorry, could you clarify, did you say that this plateau is the result of educational increase in the population? Like, is that mediating the relative risk of dementia in the population?
Right, so the relationship is that people who have more education have a lower risk for dementia. But what we often see is that when people of higher education, once they have that onset of dementia, the decline is more rapid.
Oh, interesting.
So part of what might be happening is that people who have more education have more resources to sort of, once they start having problems, they just engage other parts of the brain or have these other ways to work around. And so part of what we might be seeing in terms of the education story is that instead of having an onset at age 75 to 84, you don't have an onset until age 85 and over. Yeah. So I'm going to be focusing on data from the United States, but I do want to point out that dementia is a public health concern across the world. So in this graph, we have the light gray is showing number of people with dementia in high-income countries, and then the dark gray is in low and middle-income countries. So certainly we think about things like changing mortality and the demographic transition as some reasons why we see this drastic shift in low and middle-income countries. So we look at these sobering figures and we start to think about, well, what can we do to prevent the onset of dementia? Or if we can't prevent dementia, what can we do to delay the timing of onset? And a question from a life course perspective is, well, when do we intervene on dementia risk? So remember in the NUN study, there was a relationship between these abilities, these writing abilities in young adulthood and dementia many decades later. In this study, these abilities were also related to family characteristics from early childhood, so social characteristics like number of siblings, as well as family immigration status. So the NUN study suggests that early childhood through young adulthood might be an important time for intervention. From a neuroscience perspective, early life turns out to also be an important time when we think about the aging brain. So this figure shows on the x-axis, yes, this is time. Just wanted to point out we start in months, then go to years into decades. What's not shown on the y-axis is this is the development of synapses, or synaptogenesis. And a synapse is a connection in the brain that allows for information to pass from one part to another. And what we see is these different lines represent different complexities of functions. So the dotted line is most basic functions, and this dark line is for more complex functions. And so what we see is for basic functions, this synaptic formation is very concentrated within the first year of life. For a more complex function, we see that synaptogenesis is actually happening all the way into adolescence. So synaptogenesis is a particularly important time because the brain is most plastic as it is developing. So certainly the brain remains plastic throughout our lifespan, and so if we have damage as adults, the brain is able in some ways to adapt, but the time when it's most pliable is as it's developing. So that means when we think about basic functions, we really want to start intervening very early in life and potentially even before birth to make sure that moms are having adequate prenatal care and are having safe births. However, even if we miss this early life window because more complex functions have a longer time horizon, we could actually be thinking about interventions if we're focusing on synaptogenesis all the way into adolescence. Another neuroscience-based reason why we're particularly interested in early life has to do with the development of brain architecture. So a circuit is a region of the brain that is involved with a certain function, and a lower level circuit is when that deals with more basic types of information and passes that information on to higher level circuits. Lower level circuits develop earlier in life, so this is age on the x-axis. And so that means that whatever happens early in life, we're dependent on that for the rest of our lives in terms of more complex information. As an example, we could think about sight. So most children, by the time they're a year to 2 years old, have the ability to recognize shapes and colors. And this ability influences the ability to start recognizing emotions later in childhood. So again, because of this dependence on what happens to us early in life, throughout our life course, very early in life may be a particularly important time to focus on brain development. So in this series of projects, what I'm interested in is this relationship between early life brain and cognitive development and later life cognition and dementia outcomes. The data sets I use have really fantastic measures of cognition and dementia, but don't have any direct measures from early life because they started recruiting at age 65 and over. And it is true that most survey-based studies across the world that have great measures for older adults, in older adulthood rather, don't have these direct measures from early life. We were just talking about that one exception may be if you can link registry data from the Scandinavian countries, and there are some studies in the UK that have actually have information, direct tests of cognitive development from early life as well as measures in later life. So instead of having a direct measure, what I'm going to do instead is use the fact that early life physical growth and cognitive development have common influences of nutrition, stress, and health and illness, so that I can look at physical growth and use that as a proxy for someone's brain and cognitive developments. So I should mention in this figure, the dotted blue lines means relationships that I would like to study, but I don't have the data for, and the solid black line means that I have data and can study that relationship. So in these data sets that I will describe in a few slides, I'm going to look at the relationship between early life physical growth and these later life neurology outcomes. I'm also,
Can I
yes.
ask about should we think of dementia as being the onset of, let's say, our unit of analysis, the number of synapses you have, or I'm trying to think of some metric. Is it that starts declining at a different age? Is that how you postpone dementia? Or is it that your stock of neurons is higher? And so the reason I'm asking is I can think of this as increasing the stock of stuff, so you dementia is onset, but you just have more to lose, or something like if it's about blood flow or something like that, then maybe it's about the onset of the decline rather than the level you start at.
Yeah, so what you've just described in terms of the actual physical properties of the brain, that idea is called brain reserve. So it's this idea that people have more synapses, have larger brains, have more properties of the brain that are beneficial for cognition. And so as we start to experience declines in cognition, that you just had more starting values. So it takes longer for you to get to this critical value in which you have dementia. So that's one explanation. Another explanation is that it's not necessarily the physical properties of the brain, but it's how you utilize them. And so the second idea is known as cognitive reserve. So even if you have pathology in the brain, somehow you have the resources that allow you to buffer against this pathology. And then I think you had a third explanation, which was, or is it some other health-related characteristics like the vascular story? And that somehow early life, that people who have a more advantaged early life are able to delay these other health influences. And I think we don't know, and it could likely be all three of these explanations.
And your study design kind of is agnostic about which of those it is. It's just something in early life is helping you, and it could be any three of those stories.
Yes, so I do have information on, I have autopsy data, so I can look at physical aspects of the brain. Of course, there's a lot that's gone on between early life and older adulthood, so we just have to be careful with the way we look at those data. In terms of cognitive reserve, so this is the efficiency to buffer against neuropathology, I can also look at that as well. So what I'm not looking at is other health-related conditions like the onset of stroke, for example. But I think that would be a useful follow-up, is to understand, those pathways. Ron, did you have a question?
Well, I was wondering if there were instruments that, whatever task surveys, that have more power and resolution at the higher cognitive end. And if there are, whether you might not, or if they're not, if there were such a thing, whether you might not be able to detect earlier deterioration in high cognitive function people with lots of education and so on.
Yeah, so this is a really key issue right now, is how do we detect cognitive decline? And this is not an area that I'm an expert in, but certainly a lot of people are thinking about it. And this very point about, with education, are we sort of doing a disservice to people because they're having dementia, but we're just not catching it because our instruments aren't good enough. And actually most of the cognitive tests are meant to really separate people who are pretty cognitively impaired from everybody else. So they're not good at separating out people who have good cognition versus excellent cognition. And of course, we think about unpacking education. There's just a lot of reasons why someone with more education might perform better on these cognitive tasks. Yeah, absolutely. Okay. So I'm also interested in factors that might be related to both the exposure and the outcome. So ApoE, which we talked about before. Also education as a potential mediator, and also this potential reverse causation from education to early life brain and cognitive developments. And lastly, the relationship between early life socioeconomic status and education and early life physical growth. So just to sort of visually describe how the relationship between my data collection, so I'm not collecting any of these data, I should say, I'm doing secondary data analysis, but when the data were collected in relation to development. So all of the data were collected at age 65 and over, so that's way out here. And all of the growth and development is happening in early childhood and adolescence. So with the brain and cognition, the growth and development is accelerated until about age 7. And then somewhere, I just chose this on average, arbitrarily, sometime in midlife, we start to experience a decline. As I get closer to this age myself, I start to think like, maybe that's not the right age to choose. But everyone starts to experience cognitive decline. With anthropometry measures, head circumference is accelerated until age 7. And actually, by age 7, most people have attained 80 to 90% of their head circumference. And head circumference, in most cases, does not shrink over time. So that means when we look at someone's head circumference when they're 80 years old, we have a pretty good sense of what it was like when they were 7 years old. Arm span and leg length, again, accelerated growth early. Women peak at menarche and men often later in adolescence. Height acceleration early is interestingly related to growth in the leg. And again, peak for women around age 15 and for men into later adolescence. With height, we know that people shrink over time, and that's primarily because of spinal shrinkage. This is particularly an issue for women. So when we look at someone's height when they're 75, we do need to think about what's going on with their spine. So that's why some of these other measures like arm span and leg length might be useful proxies of maximally achieved height, is because these measures don't experience the same type of shrinkage as spine. Yes?
So I recently heard a talk that was talking about research, so it might not have been accurate, but it talked about the recent research about the adolescent brain, and that the adolescent, like the development is really important, but the sense of adolescence was much broader than I'd ever conceived of that. Starting around ages 9 and 10, going to age 25, which is most of our undergrad students are actually adolescents, and some of our grad students. And talking about, so I was curious about the timing. You know, I understand, a lot of research is about early childhood and how important it is, but it seems like the research that I don't know, that you know far more about brain research, is actually this time of adolescence up to the age of 25 is really, really important.
Yeah, so, and I think part of that is because of the education story, right? Is because many people, especially if you go on to college, that education is happening into age, like into the mid-20s.
So my understanding was that actually there's things going on, and so that the way it was described is like that your brain is offline for like a lot of those years because of the actual biological things that happen.
I see what you're saying, okay.
That are I think sometimes related to education, but not, and it makes it kind of a particularly susceptible, vulnerable time.
Did you have
Well, just related to that question, I think you find major sex differences in the brain development through childhood and adolescence that might have shown up on your earlier charts of the curves, where the cognitive, the sort of higher executive functions of boys tend to be much later on the curve than for girls. It has to do with their growth, but that usually boys are about 1.5 years, 2 years behind the girls. So it'd be interesting all the way through this to know what the sex differences are, right? I mean, it just has to do with the adolescents in particular.
Yeah. So I'm still learning about neuroscience, and I had not heard about this research, but I think, the brain is a mysterious organ because it keeps changing all the time, and so I think our knowledge of it is still growing, and so I'll definitely keep that in mind.
So we have 10 more minutes of regular talk, or if you have
Okay.
questions, and
Yeah.
go a little over if you want. But
Okay, yeah, great. Okay, so our hypotheses are that shorter stature are related to lower level of cognition and faster decline. Early life human and financial capital partially account for these relationships, and that education mediates these relationships. So I am using 4 data sets in this project. They're all population-based data sets from across the United States. They all have very different populations though. I chose this collection of data sets because they all have autopsy, and they all have measures, some sort of measure of early life development. Some of them have anthropometry, and others have retrospective questions. I'm going to focus on results from the Adult Changes in Thought study. So this is the study based at Kaiser in Washington. The study started in the mid-1990s, and they started replenishing the cohort in the early 2000s. Average follow-up time is 10 years, which for a study like this is a really long time. And all of the data sets that I'm using today are publicly available, so that means if anyone here is interested in using these data, please get in contact with me and I'll let you know how to access them. So in the ACT study, I'm going to use the first measure for height, lower leg, and arm span. And about 50% of people have more than one measure for these. And for head circumference, I'm going to take the average measure, again, because we don't expect that this is a measure that should shrink over time. And I'm going to use the quartile distribution for these variables because I'm not sure if there's a linear association or if it's just the case that people who had the smallest measures and were the most affected, severely affected, would have greater risks for cognition problems later in life. In terms of early life socioeconomic status, people were asked about parental education for both parents, were asked about financial stability up to age 15, and were asked about the ability to afford basics and small luxuries. And I'm actually going to keep these separate because I want to look at this potential difference of human capital from early life from financial capital from early life. In the analysis, we're also going to pay attention to sex, baseline age, and ApoE genotype. And also education. This is a pretty educated cohort, so I can only, the cut point that makes sense is to look at up to high school versus college or more. I don't think that that's necessarily the most important cut point for the relationships we're looking at. I think that if someone completes less than high school education, that would be important to know, but we just don't have the variation in this cohort. So just a quick detour about education and the way that social science thinks about education and the way that neuroscience thinks about education. And this is actually some previous questions brought up these points. So I think as social scientists, we think a lot about education in terms of human capital as the investment in skills, knowledge, and capabilities that contribute to greater productivity over the life course, and we can measure productivity in terms of income, health, and wealth. From a neuroscience perspective, education is often seen as an important component to building cognitive reserve. So this is getting to Josh's question. Cognitive reserve is this ability to buffer against neuropathology. So if you looked at two people who had the same levels of neuropathology, one person may have been very severely disabled cognitively during life, and the other may have had no problems. And so that person who had no problems, we would say, had more cognitive reserve than the person who was disabled. So from both of these perspectives, the bottom line is that education leads to better health over the life course. On the person level, education is going to decrease dementia risk, and on the macro level, we can think about education as a possible pathway to offset some of the economic changes associated with population aging, and in particular with increases in dementia. So coming back to the study, the outcome we're going to use is the Cognitive Ability Screening Instrument. This is an assessment of global cognition, and it's given every other year in the study. There are 25 questions, score of 0 to 100. And this comes back to Ron's question about how good are these cognitive tests at discriminating against different cognitive abilities. So we know that this test is meant to really separate people who have true cognitive impairment from everybody else. It's not good at separating people with good cognition from those who have excellent cognition. So we use, and so one of the properties of the scale is that it's non-linear, which means that a 1 unit increase in the score has a different interpretation depending on your starting value. So we use a technique called item response theory to transform the data such that a 1 unit increase has the same interpretation no matter where you start. And when we use this transformation, our median is 0.5 with a range from -4 to about 1.75. So it looks quite different from the original score. So one of the questions I want to answer with my statistical analysis is anthropometry related to cognition? I'm going to use a linear mixed effects model. This is a model that's going to account for repeat outcomes and is going to look at differences in the starting level of cognition as well as differences in cognitive decline. The second question I want to answer is, does anthropometry influence cognition via education? And so here I'm interested in mediation. I tested the assumptions for traditional mediation methods and found that those were met. If anyone has questions about what this means, feel free to ask me. And lastly, I'm going to run separate models for men and for women. This gets back to this previous comment, differences in terms of growth timing and differences in attained size. So some key sample characteristics by sex. So this is just the sample size for men and for women. Everybody who had all of these characteristics and at least one anthropometry measure. Most of these variables have a similar distribution across men and women except for the anthropometry, which is what we were expecting. If we just look at the mean value of this CASI score over time by height quartile, so this is not accounting for attrition, just look at the mean value, we see that the shortest women, so this is the blue line, that they start with a lower CASI value and also have a faster decline. When we look at men, we see that they start with a lower level, but that the decline kind of looks similar to men in all of the taller quartiles. When we then use the models, we find that for women, now we don't see so much of a difference in terms of starting value, but the shortest women who are in the blue dots do have a faster rate of decline. For men, we continue to see this gap in terms of starting level, but the rate of decline, so if you look at the slopes, looks pretty similar to men who are taller. In men, shortest arm span, also related to faster cognitive decline. In women, that was true for shorter leg length. Head circumference was not related to cognition, either starting level or decline in this population. And so that's, again, that did not support our hypothesis. And the inclusion of the ApoE genotype did not alter these results. So just some limitations. Every time I give the study, someone raises their hand and says, I'm short and I don't have cognitive decline. So what's going on with your study? Yes, yeah. Certainly there are genetic differences. Studies that have looked at more genetically homogeneous populations find results pretty consistent with what we find. And an important point is that gains in height in the 20th century have been too fast to be only related to genetics. So there is an environmental component. Models don't account for attrition due to mortality. That's something I'm still thinking about because you can think it makes sense that someone's going to have cognitive decline close to their death. Lastly, sample selection. Our combined sample for men and women is about 3,500, and there are 5,400 people in the overall study, so we need to understand more about why are some people not being selected into the final analyses. We thought arm span was going to be a good measure of maximally achieved height in people who had spinal shrinkage, but it turns out that it's difficult to measure height in people who can't stand up straight, and it's also difficult to measure arm span in those folks. So leg length may actually be a better measure for people who have substantial shrinkage in the spine. I just briefly want to talk about some extensions to this study. The first is to understand neuropathology and where that fits in. So this is Stephanie Izzard, who's an RA working with me, and Hen Piotrowski is another RA working with me on this project. So basically, we want to understand what's this relationship between neuropathology, these earlier exposures, and these brain outcomes. So we're just at the beginning stages of this project, and this is just to show what the outcome variable looks like. So interestingly, almost everybody has some neuropathology. A fair number of people have 2 types of neuropathological lesions, and then some folks actually have 2 or 3 types. And so from our hypothesis, we would expect that people who had a more advantaged early life would have lower risk for neuropathology. And our results actually don't show that. We see that there's no relationship between early parental education or any of our other early life socioeconomic measures and the distributions of these outcomes. Something else I started thinking about was how has the meaning of education changed over time? So this is my grandpa Ed. He moved to the United States when he was 15, and he actually completed high school in Washington State. And after he completed high school, he went to work because that's just what you did then. And I started thinking about the difference between him completing a high school education and what would have happened if I stopped school in high school. I'm just starting to think about, well, in these studies, we're looking over a broad range of birth cohorts, so maybe we're missing some subtleties. And this is just a depiction of the cohorts and birth cohorts and entry years for the ACT study. And so something important to point out is that in no year can we capture every single birth cohort. And when we think about these differences, there's a lot going on across these cohorts, a lot of differences, both in terms of early life exposures and in terms of the adult experience. So Manali is one of my other RAs who's helping me on a project where we want to look at the relationship between birth cohort and incident dementia. And again, we're just at the beginning stages of this project, but we definitely see differences, social differences by birth cohort. This is just, we looked at the distribution of parental education and cut it in half, and so this is people in the top half. And lastly, this comes back to Josh's question about what about these other pathways that happen over the life course. So Anna is another RA working with me. We're actually interested in our primary exposure variables of socioeconomic status across the life course. And we also want to understand, well, what about these time varying potential confounders and mediators over the life course? So longitudinal data is a wonderful thing because you can explore these measures, but it's also sometimes a dangerous thing because it can be really messy. So again, we're just starting to think through this model. And I just want to end with a story about my other grandfather, because I've spent the last 45 minutes trying to convince you that having an advantage early life is really important for later life brain outcomes. But my other grandfather was not, so he stopped going to school in 3rd grade, and he was never functionally literate in any language. He taught himself English when he moved to the United States. He lived to be 94, and he only had decline in the last 18 months of his life. So he's a reminder to me in this project, we're looking at group differences. There will always be exceptions. And that I'm certainly not capturing everything that matters for later brain health in this project. And I think in the case of my grandfather, he had a very tenacious personality, and I think that's why he was so successful in his life. Lastly, I just want to thank the people who have supported this project, in particular the participants and families of these studies, and then welcome your questions and comments. Thank you. Yes?
So I want to ask two things. Sort of the APOIE, you said the inclusion of it didn't alter the results. Do we know what that sort of gets at and how good at capturing risk of dementia that is? Because from my understanding, there's a lot we don't know about dementia still, right? Is that not the case? And then I also wanted to ask what your sort of sample looked like demographically, because there's some evidence, a paper came out like a few weeks ago that showed that like some of the genomic scores didn't hold for other like racial ethnic categories. They mainly hold for like white European folks. And so I'm curious about that. And then it's also interesting because another paper by Patrick Turley came out that said that like basically education mediates obesity risk, like basically these genomic risk scores. So I'm curious what you know about all of those things. Sorry, that's a lot.
Yeah, so did you have a,
No, sorry, but when you're done.
Oh, okay, absolutely. So APOE, my understanding is across studies and populations has been a pretty consistent risk factor for Alzheimer's disease, not for the other types of dementias. And so I believe your increased risk is about 20%, so it's not gigantic, but it's also not negligible. And I think you need to consider APOE with respect to everything else that's going on with the person. But certainly an important genetic marker to take a look at. So absolutely, we have this problem, and this is a problem in my studies, that it's mostly people of European ancestry, except for the Honolulu aging study, which is all Japanese American men. So that's one of the limitations of the data I'm using. At Columbia, there are several cohorts that sample from our local area, and which is predominantly Dominican, and some African Americans and Puerto Ricans. And so I'm thinking of some extension studies to start to incorporate a more diverse group. And yes, absolutely, you need to incorporate you can't just look at genetic risk scores from these populations and apply them to a more diverse group. Yeah.
I just want to apologize ahead of time if this is a nitpicky thing. I know that you, in your final analysis, didn't include measures of weight at all, but it sounded like that's something you're interested in the future. Mm-hmm. And I come from a social science background where, at least the research that I've read, says that weight is often a proxy for things like cardiovascular health due to exercise. And I know that a lot of times fat people already have like a harder time getting good health care. And so I wonder whether, I know no data set is perfect, but I wonder whether you've given any thought to different terminology and whether using terms like obese and fat is really the best measure of what you're getting at with that sort of variable.
Yeah, so just to kind of turn back to that comment, I actually never did anything with the weight variable because I'm not, like the vascular pathway is not necessarily what I'm interested in. That's a really good point though, that weight is also a proxy for other social exposures. And I hadn't thought much about the terminology used, but certainly especially for that really busy graph where we're starting to look at time varying confounders, that's definitely something that I'll make sure to pay attention to. Yeah, thanks for that comment. Ron, or Josh?
I'm thinking of height as a measure of childhood SES, as we started out talking about Fogel and so on. And I'm thinking really what we would want is height relative to what one would expect based on genes. And now, with HRS and lots of studies, you can do polygenic risk scores for height and then measure actual height relative to what you would expect, and maybe that would be maybe people are doing that. It seems like a natural thing to do. And then is there a parallel operation that might be done with education? Because when I think of education, okay, we have lots of these polygenic studies that find quite strong effects on educational attainment. And so we're going to get, thinking of your second grandfather who went through third grade or something, we're going to get maybe 3 signals from actual education. One of them will be some genetic predisposition. One of them will be socioeconomic circumstance of the family relative to others. And the third will be this cohort effect that you mentioned. And how to sort those out, I'm really not sure, but there might be it might be interesting. Probably people have looked at polygenic risk score for education in relation to dementia in later life, which now is possible with these big HRS type surveys and maybe others as well.
Yeah, so I've certainly looked at polygenic risk scores for height, and we've actually done some predictions, and it's just the risk score is still accounting for too small of a percentage. So the residual you get you can't quite make sense of it yet. I haven't looked into the risk scores for education, so that's definitely something that I'll take a look at. Yeah, thanks. Josh?
So I wanted you to go back to your 2 basic results slides with the men and the women and just hear your gloss on it, because it went by quickly. And so I know you haven't proved anything yet because you're still early on, but what are you thinking? Why is there this different effect for men and women, and what does it mean?
Yeah, so coming back to this, now she's not here, but there was an audience member who made a comment about the differences in acceleration for growth and development for men and for women. So part of what we might be capturing is the fact that for women, height is pretty much set by early adolescence. And then if we think about what's going on with brain development and learning skills, that there's, like, that's my son, sorry. So what we might be capturing with height might be, the bottom line is what we're capturing with height might be different for men and women. So we might be capturing earlier development for women than for men.
But I feel like you're just one step ahead of me. So what I make of the fact that that everybody starts at the same place and that the shortest people decline the fastest? I just don't know how to interpret it. But this is for women, and then for men,
Yeah,
I think
for men
it's the parallel lines.
Different
intercepts.
So the way I interpret this is that, so something about height, whatever it's capturing, in terms of cognitive development, somehow that it's allowing women to better stave off cognitive decline. For men, whatever is going on,
First the child screams, then the computer turns off. They want to tell us that time is out.
Yeah, so thank you. For men, whatever is going on is allowing for this difference. So if you were to look cross-sectionally at men over time, you'd see a difference in the level, but not necessarily a difference in decline. And so I think so you think about the life course, what we're trying to prevent in older adulthood is decline. Like you can't really, if you're, especially when you're looking at older adulthood, you can't necessarily change what someone's starting value is, but regardless of what someone's value is at any point in time, you can try to intervene on their cognitive decline. So so in terms of an intervention, I don't know, I haven't thought that far in advance, but I do think this means that HEI is capturing different parts of development for men and women that might have different implications for what's going on in the brain later in life. Yes, question here and then.
Sorry, just to add on to that, it does seem that for men, the cognitive decline for the shortest group does seem to have a steeper slope than for the others. So it might be that for men, cognitive decline happens earlier than at the start of the study when you started recording the CASI data.
Yeah, that's a possibility. Yeah. So these shortest men do have a slightly greater decline, if not
So it could be that for men, you have to start the study a bit
Earlier,
earlier
yeah.
in order to detect the cognitive decline.
Yeah, that's a good point.
For women, the cognitive decline happens later, but it's more steep.
Zero here is some like age standardized time in your regressions. I mean, everybody doesn't start at the same age necessarily, be kind of, zero is kind of standardized for age.
Exactly, we standardize for age. Yeah. And was there one last question here? Yeah.
So I wanted to ask if this difference that you're seeing as people age with this pathology could be attributed to early life nutrition, and if that is like a good proxy for essentially your economic status in the early years of life, and that is why we're seeing education. Because a higher SES leads to a better education typically.
So that's exactly the theoretical pathway
Okay.
that I'm thinking of. And just it's a lot to take in all at once, but trying to figure out how to model those pathways.
So I guess one empirical question is that relationship different for men and women? Height may be a much bigger advantage for men in terms of educational attainment than for women, just because of the social processes going on early in lives. I mean, that might.
Yeah, it's a good point. I haven't looked at that yet. Yeah.
Did you show us the data these were fed to in the slide before this, or am I?
Sorry, this one or what?
Maybe. Is this what those regressions were fed to, the models? This is more of a clarification.
Oh yeah. This is just the
So it looks like they increase and then decrease. Is that?
Yeah. So when these are totally unadjusted, so I think
Okay.
there might be something going on.
Okay.
Some age differences. Yeah.
So what? I see. So what Josh is talking about, the standardization takes care of. Okay.
Yeah. Probably.
Yeah, so if you think about it, getting back to previous discussion about the mediating role of education between anthropometric measures and cognitive decline, these generations were growing up at a time when men had higher level of education and other times. So is it possible that it was a looser relationship between anthropometric growth and education for women than for men, in which case it's not so much the relationship between anthropometric measure and cognitive decline, than about the interrelation with education. So women who, taller men were more likely to be educated, but taller women were not necessarily more likely to be educated because at the time women just didn't continue studying all the time. And so you would have some different relationship for men and women there.
Yeah, so I think if we could look at the whole population of these ages, that would definitely be true. This is kind of an unusual sample though, because the distribution of, women are slightly more likely to have only graduated after high school. So I think, so understanding more about social norms, and that's also part of the reason why I want to look at these differences by birth cohort, is to start to tease those apart. Yeah. Ken?
So I was returning to Ron's comments on polygenic scores, and I take it that these, for a subset of these people, you do have genome-wide data. So
For all of them, actually.
for all of them. So it's relatively rare to have such strong correlations and trajectories of height and early anthropometric measures with these kinds of cognitive and health outcomes. polygenic scores, which we now have coefficients for all kinds, there are a lot of polygenic scores around, but those coefficients often tend to be very closely related to each other, correlated with each other, even when the traits are at great distances. And some of this is interpreted as taking in a lot of what the educational attainment score, plus the Alzheimer's score, plus the height score, plus all of them, are picking up some kind of underlying cellular physiological robustness. There's a bunch of shared variability that is not specific to the trait. And when you get polygenic scores, you're looking at a lot of alleles that are broadly about the viability of the organism. Now, you're in, I think, an unusually good position to look closely at that issue, since for once you have something where height, so you're finding a strong association between height and the CASI score in later times, and so partially that out through the polygenic scores from which coefficients are tying into that association. So a lot of this is looking at just the genes, the genetic scores, and the traits. But you have something where there's a height by CASI score correlation, and so you can look at what part of the genetic predictors are explaining that correlation, not explaining the traits themselves. So it seems to me you've got a big opportunity there if you're going in the polygenic score direction.
So yeah, maybe we can talk more about the details of how to do this, because I tried to do something last year and it didn't work. So yeah, your guidance would be very helpful.